Christine talked about all the shiny new future stuff. And I actually want to take a step back and look at the big picture. I feel like the running joke of 2026 so far has been us rediscovering first principles. Oh, wait. You mean we should have fast feedback loops? Oh, wait. So tests are important, you say. Are you insinuating that we should talk to our users, to each other, over and over again? These are things that have been true all along, but now they're so true. So as we kick off our Innovation Week, I want to take a step back and zoom out. What are we here to do? What are we here to achieve? What is our purpose? And as everything seems to be changing, as every part of the way that we build and understand our software is being given fresh scrutiny, what matters and what doesn't. We're here to build. We're here to create value. We're here to try and make a difference in the world. Just start with what matters, right? Always have to start by asking, what are the outcomes that we're aiming for? And then you work backwards from that. Outcomes are the North Star because speed, code quality, features, feature completeness, usability, onboarding, reliability, these are all signifiers of excellence that derive from very specific outcomes. And it's been easy to obscure this in the past because of the complexity of each of our domains. One of the biggest original consequences of that complexity was a carving up of the domain of software into development over here and operations over there. Or if you're reading the software development lifecycle, it's just maintenance. But dev and ops were never supposed to be about these people write code, these people operate it, let alone some kind of like hierarchy where some are good and some are just dead weight. It's a separation of concerns. Everyone builds. Everyone needs to be responsible for what they build, right? And the dev versus ops duality is always going to be with us. I say this as someone who spent many years trying to tear it down, but it's always going to be with us, I realize, because it is about the tension between the need for change and the need for stability. Everyone needs both, and it's encoded in a way that makes this tension legible to organization charts, funding, businesses, priorities. This is a development feedback loop, and it has traditionally looked like this. Build, test, merge, or if we're being honest, it's more build, test, build, test, build, test, build, test, build, test. Okay, it's fine now. Merge. Cool. Where's production? It's not there. It's not there. Developers have historically lived in a cozy, insulated little padded cell of how things should theoretically work. It's a lovely world. I can see how one might want to live there. Their tests, they build, they test for the behaviors that they expect to see to the extent that they can predict them. And then they merge. Their feedback loop starts with intent and it ends when they decide it probably works. Then they merge. Development over. The development loop. And it's all about introducing change into systems. On the other hand, the operational feedback loop is about stability. It's about durable code, durable results. It's about stability and it's about, and you can see how there's a natural tension here. The operational feedback looks like an alarm goes off, you go and look at it, and then you fix it. Alert, observe, fix. And production is a very noisy place. If you are doing tens of millions of requests per second, you can understand why the threshold for what constitutes a threat is quite high. It has to be, or your phone will literally melt in your pocket, right? So the operational feedback loop that defends the health of the system, it gets kicked off when someone complains loudly enough or when a pager goes off. But in order for that to start, it has to literally threaten the integrity of the system. These are two very different loops, don't overlap at all. And neither of them actually connect the dots between the intent over here and the validation over there. That's the loop that actually matters, right? And the loop that matters looks like this. This is the feedback loop of value creation, of developer intent, validation, and learning. If you care about outcomes, this is what you actually care about. What does good mean? What does productivity mean? What does it mean to deliver results faster? Which results? For who? Why? These are muscles, to be honest, that are weak for us, for all of us. These are muscles that are weak for us, but we must build them. Christine talked about how the software development lifecycle is being compressed or collapsed, and how what remains is this: developer intent and validation. Does that look familiar? Like it's our old friend, the value creation loop. It's exactly the same thing. It's developer intent, and then you observe, and then you learn. You build, observe, and learn. We still need change. We still need stability. Some would say more than ever. But this is what is so actually exciting about this moment in time, right? It's that the feedback loop of value creation has never actually been accessible for most teams because it spans these two disciplines, and now it is. But to get there, to hook up these feedback loops that let us move swiftly with confidence, we have to dispense with the fiction that production is somehow disconnected from development. It is not. Production is a stage of development. It always has been. I just want to point that out. Production has always been a stage of development. It's not that you develop and then, it ends and then we go to production. No. It's just that right when your code was ready to be born, you walked away from it and gave it to someone else. Suffice it to say, production is not what happens after you develop. It is actually the only test that ultimately matters. Software engineers are not responsible for creating value in theory, but in reality. And yet, in reality, their tools have only ever really validated in theory. Production is nowhere in the loop. There is a yawning gap between the developer loop, which pushes change, and the operational loop, which protects stability. And that gap looks like this. The space between these loops is where most learning goes. And by goes, I mean it gets dropped on the ground. Software engineers are using tools that were handed down from infrastructure teams that are good for infrastructure, and they're not, and operational teams need to keep that threshold high. Nobody's looking at this hole. And this gap costs trillions of dollars worth in lost productivity and burnout and value that was never captured or understood. Why? The labor of instrumentation and, it's been a very heavy lift. The context switching, and the thing is that AI attacks so many of these fronts at once. It attacks the auto instrumentation. It attacks that you don't have to learn a whole new suite of tools. You can make the feedback loops come to you the many different ways at once. And the cost is dropping lower every week. And it's becoming too expensive not to change. Because if we do not encode our wisdom into the system, it doesn't exist. There are teams out there, and probably most of our teams, are ones where when there's an outage or an incident, it might take on average, 45 to 60 minutes to restore service, unless one or two particular engineers show up, in which case it regularly takes about 10 or 15 minutes. This is not a good thing. This is a sign that the wisdom that we rely on only lives in a couple of heads instead of it being a trade off. In the past, it was a trade off between you've got a fixed pool of engineering cycles. You have to decide whether to allocate that pool to building new features and product for customers or to building the guardrails to help your reliability and your resiliency and your testing and all this stuff. And like, no surprise, most of those cycles went to the things that actually keep most businesses from succeeding and competing in the market. But that sort of prioritization is flipping because now, if you want to build at the speed of AI, you have to invest in those guardrails in order to do that. And AI is bringing down the cost of doing this. It is becoming accessible for every engineering org. All right, let's say the top 80% of engineering orgs. It's becoming much more accessible. And agents in particular are really forcing this issue because there's no such thing as being able to predict what the agent's going to do in production, write a bunch of tests for it, and ship it. The only way to know is by instrumenting your agents and watching them run. And then, once you see what it does, you can pick the right evals, backport them to your pre-production testing. But this is exactly the opposite of how we've historically done things. But it turns out agents aren't that unfamiliar for us. They need the same thing. They need context. They need speed. They need connective tissue. They need the ability to iterate and explore and follow the trail of breadcrumbs. The ability to follow our code into production and understand it there is what matters. So, what have we learned? What truths about observability do we need to carry forward into the agent era? Your instrumentation is a product decision, not an infrastructure decision. Understanding the intersection of software, system, software, infrastructure, users, usage patterns, and data at a moment in time. Every single one of those moments is unique, will never happen again. So keep your signals packed together, unify against a single rich data source like traces, as rich as you possibly can, because the value of your data increases not only exponentially, but combinatorially with every additional attribute you add. And bring down the DevOps divide. Let developers and agents finally treat production like what it is, the last and by the, the last and most important stage of development. In conclusion, do you know what actually creates a feedback loop? It's observability, the cause and the effect. But if you don't observe between them, no loop, no ollie, no loop. And the speed and the quality of your feedback loops depends entirely on the quality, precision, and speed of your observability. Observability that is lossy, laggy, imprecise, lacking in detail, doesn't let you learn from the software that you should. That's why I know we have a lot of big, ambitious AI goals over the next few weeks, months, years. I'm sure you do too. Every single change that we want to make, every single goal that we have set for ourselves will only be as good, as fast, as precise as the feedback loops in our socio-technical system. And that starts in an extremely literal way with observability.